Hi everyone, today I'm going to show you on the drawing of cyclic sugar in Haworth projection. So I'm going to show you the drawing of furanose and pyranose for aldose and ketose. So the example of aldose that I'm going to use here is d-ribose. So firstly, for you to convert or draw cyclic sugar, for any sugar, first you have to know the Fischer projection of the sugar. So this is the d-ribose, the Fischer projection for d-ribose. First, we can do the numbering on the carbons in the Fischer projection. Carbon 1, 2, 3, 4, 5. And since now you want to draw the furanose, then you must know that furanose is a 5-member ring. Okay, it's a 5-member ring with oxygen. And for the formation of furanose and also pyranose, you'll form a pairs of anomers, the alpha and beta anomers. Okay, so now let's convert the Fischer projection to Haworth projection. Now we can do the numbering for the carbons in the ring. We start with the carbonyl carbon. The carbonyl carbon in aldose is carbon number 1. So here we'll start with carbon 1, 2, 3, 4. Okay, so you also have to know that the group on the left of the Fischer projection will be facing up. The groups on the right of the Fischer projection will be facing down. Okay, it will be below the ring. And let's start with carbon number 1. Okay, carbon number 1 is a carbonyl carbon. So when this straight chain, open chain sugar forms cyclic sugar, the carbon double bond O will change to be converted to carbon single bond OH. It can be either up or down. So this is why you have a pair of anomers. And then let's move to carbon number 2. The OH is on the right, so it is down. Carbon number 3, OH also down. Okay, carbon number 2, number 3, the OH, they are on the right, so they are facing down. And for carbon number 4, you don't have to draw this OH down, because you have to know that this OH is the one that having reaction with the carbonyl to form the ring. So this oxygen here is actually this oxygen in the ring. So now let's move to carbon number 5, which is the CH2OH. CH2OH is attached to carbon number 4, CH2OH. So you have a CH2OH group here. Okay, so for the anomers, you have the orientation of OH the same with the other anomers. Okay, so this is beta, this is alpha anomers. Next, I'm going to show you the drawing of pyranose for this d-ribose. Okay, so similarly, we can do the numbering for the carbon in the chain and draw the pyranose ring for this sugar. The pyranose ring is a 6-member ring with an oxygen, and do the numbering on the carbon in the ring. Start with the carbonyl carbon, 1, 2, 3, 4, 5. Okay, so carbon number 1 in the chain, it was a carbonyl carbon, C double bond O. So in the ring, it'll become single bond OH. Single bond OH, one up, one down. Okay, this is the anomeric center. This is the newly formed chiral center. And carbon number 2, okay, so the group on the left will be up, the group on the right will be down. Carbon number 2, 3, 4, the OH, they are all on the right, so they will be down, down, and down. Okay, so it is the same on the other anomer. And now you have carbon number 5. Okay, the carbon number 5 is already part of the ring. Okay, so this carbon number 5 is already part of the ring, and this oxygen is the oxygen in the ring. So this is the pyranose for d-ribose. This is the alpha anomers and this is the beta anomers. Okay, remember alpha, beta refer to this hydroxyl group. Okay, when this OH is down, like alpha, okay, this is alpha anomer. And when this OH is up, like how you write beta, okay, so this is beta anomer. And next, let's look at this drawing of furanose for ketose. And I use d-fructose as an example. So first, let's do the numbering on the chain. 1, 2, 3, 4, 5, 6. Okay, so now we want to draw furanose. Let's draw the furanose ring, which is a 5-membered ring. And carbon number, okay, so now we have to do the numbering in the ring. Okay, start with carbonyl carbon. In ketose, carbonyl carbon is carbon number 2, so we start the numbering with 2 here. 2, 3, 4, 5. Okay, so now let's look at carbon 1. Carbon 1 is a CH2 OH group attached to carbon number 2. Okay, so you have two possible orientation. One is up, one is down. And carbon number 2, the carbonyl, the carbon double bond O, now become carbon single bond OH. And the group on the left is up, the group on the right will be down. Okay, so you have up, down for carbon 3 and 4. So you have up OH, down OH. And carbon number 5, okay, remember you have to be careful with this. You do need to draw this OH down of the ring because this oxygen, okay, is already part of the ring. Okay, you can see this oxygen attached to this carbon number 5. Okay, so we have done with carbon number 5, and now next move to carbon number 6. This CH2OH group attached to carbon number 5. You have one carbon number 6 CH2OH group. So This is the alpha anomer, and this is the beta anomer. And lastly, let's look at this drawing of pyranose for this d-fructose. Let's do the numbering. 1, 2, 3, 4, 5, 6. And next, draw the pyranose ring. Do the numbering in the ring. Okay. Start with the carbonyl carbon, ketose. Carbonyl carbon is carbon number 2, so we start with carbon number 2, 3, 4, 5, 6. Okay, now let's look at the carbon one by one. Start with carbon number 1. Carbon number 1, CH2OH. So this CH2OH attached to carbon number 2 can be either up or down. Okay, you have a pair of anomers. And carbon number 2, the carbon double bond O becomes single bond OH, single bond OH. And remember this. So carbon number 3, OH up, 4 down, 5 also down. So you have up, down, down at carbon 3, 4, 5. Okay, up, down, down. Okay, up, down, down at carbon 3, 4, and 5. And for carbon number 6, the CH2OH group, you can see you have carbon number 6. In the ring also you have the carbon number 6. So carbon number 6 is already part of the ring. This oxygen in the ring is actually this oxygen that attached to carbon number 6. So this is how you draw pyranose for d-fructose. That's all. Thank you.